Today we are looking at hyperbola. We have been treating so many other topics, and so what's an hyperbola? Hyperbola is, I would say, in my own simple way, is the reverse of the ellipse. Remember, the ellipse has a shape like this, in which it cuts the x-axis twice and it cuts the y-axis twice also. And so it now ended up, this is the ellipse, just for a reminder, okay? And then obviously this is A, this is the longer side, was A, right? This will now be minus A, that's in the reverse. Are we following? Okay, and then this was B, or this is minus B, and then this is B. So here A is bigger than B, and then obviously this is the x-axis, this is the y-axis, okay? And so knowing that, so finding the equation of it, depending on how this ellipse is increasing, now give us a formula for this as x squared over a squared plus y squared over b squared equals to 1. Now take note, this is for this shape, while if it was now in the reverse, this ellipse, in this one now, we have, this is a lesser than b, I mean b is greater than a, then y squared now came first over a, just so that it will be balanced. And then x squared over b squared is equal to 1, because in this one b is greater than a for this. So understanding that, we're now going to the hyperbola. The hyperbola is simply the reverse on the shape of the ellipse. So what we are saying is that this shape, instead of it being like this and like this, is now in the reverse. It's now like this and like this, and then it's now like this. So let's use this. So it has two forms. It will come. This is what we call left and right. Okay, this is the left and right. So the parabola is formed from cutting of two cones, cutting of two cones, or you can see cutting of two. What else do we say now? The curves, cutting of two circles. Literally, it's a plane that cuts two cones. That's the literal definition, okay? But not using that, we say it's just the cut of two parabola. These two parabola facing three different directions. So one thing is very clear from what we have here, from this shape that we can see. About this is x-axis, is that also? So this left and right. Remember, this was up and down. Now it now turned. What was up and down now turned. So this is up and down, the reverse of up and down. It will look like this. Do you understand? So remember, when it turned around, it touched, became ellipse. Now in the reverse. Now take note, how many vertices does it have? It has two vertices. Okay, still one focus, two vertices. That other one had four vertices. Remember, one focus, and then that was that. So this one now has what we call two vertices, because there is one vertex here and the other vertex, but the values of the vertices are the same. Okay, two vertices, but they put them together. Remember, and then there's a distance between them. So there is an introduction of a new term, which is h and k, because these vertices normally have a center. Now we are just assuming that the center is at 0. In this shape now, our center h and k lies at 0, maybe somewhere here, based on how we measured it. So this value here, okay, so no, at this point it's here, okay? So the center we represent as h and k, okay? In a hyperbola is h and k. Let me work this way so that we'll be able to understand. So I'm just trying to break it down. You may not find this in most textbooks or anywhere online. You may not find what I'm teaching you today. So just try and follow me, okay? I'm giving you vital information. Alright, so we have x-axis, y-axis, as always, okay? So at this point, the center h and k. Now between here and here, there's a distance, okay? There is a distance. Also, the distance can be, remember the center h and k, distance most times is a. Remember, the reverse of it will be what? Minus a, okay? So therefore, we have what we call this vertex. The vertex is h plus or minus a, h plus or minus a and k, which means these are two. So we have h plus a k, and then we have h minus a k. That's what it means. That's what we are trying to tell you with this h plus or minus and a k. Okay? Is that a plus or minus? That's for this point and for this point. But the focus is one, and the focus is also what we'll call h plus or minus c and k. Now that's for this equation. So the general equation for this is actually what we'll call x minus h squared all over a squared minus y minus k squared all over b squared equal to 1. Now this is the equation for the hyperbola, for the left and right hyperbola. Is that okay? Now don't get carried away with this my vertex, okay? This is one vertex and this is another, but it's just like a reflection of it. So most times the normally say it's the same. So most times we just say it's the same. And then the focus is also it's a reflection. Okay? So almost looking like a reflection. So that's a value. That's the value. Okay. So this is the equation for it. For the left and right. Why if we have it in the reverse? Remember this is h. The focus is h. The h we talked about the center plus or minus the a. This takes us to the vertex. Is that also? That's what it does. Takes us to the center. So if we had the reverse of it, now it's now up and down. Okay? There will not be a twist. Now we now have y minus k squared all over a squared minus hx minus h squared all over b squared. You know why we are picturing h? Because the center is not always at this point. You know these two can shift to this point. If they shift to that point, take note, picture it. You find out that their center will not be the center. So whatever value it is, it will now be added or subtracted. Okay, so in this my shapes, I'm assuming the center is at what? 0. So assuming the center is at 0, this is equal to 1. Take note. To complete the equation is always equal to 1 x minus h squared. Now in this case, it's now reversed. Instead of h, we're now dealing with k. In this one, the vertex is now what? K plus or minus a h. Okay, and then the focus is k plus or minus c and h. Okay, or we can still write it the same way, just that this time we can, instead of putting it this one, putting it that way, so you know, you say h k plus or minus a, because this time when it's now in the horizontal, in the vertical, it's now in the vertical format. So the k, this is now k. Remember this is not dealing with k, because k is a vertical. This is a vertical side, right? So we're dealing with the k, and therefore it's no more like when we're dealing with. And then the distance is still a, but then there is another, in case it shifts. If it shifts down, if this one is not in this point, it shifts down a bit, you will now have to add the a to it. Or because I'm still choosing to use a, but if I choose to use b, it will now be what? Plus or minus b. Okay, that will be the accurate value, because this is b, you know, because it's breadth. Okay, so we have h plus or minus b, and then we have h k plus or minus c. So it remains the same, but this time it's k we are using. K plus or minus what? C. C is the center. Now what's square C? C is actually what? A squared plus b squared. Okay, it's in Pythagoras. So if we have value of a and b, you can always get c. Once you know the value of a and b, we can always get c. So this is the hyperbola, the long and short of it. These are the equations of the hyperbola. Like I always say, once you know where it's derived from, every other thing falls in place. Once you know where it's derived from, every other thing falls in place. So I said two vertices. This is one. This is another one. These are vertex. So that's why I said it's two vertices. Okay. So that is the basis of it. Now, if you find out one thing about the ellipse was that you saw the x squared, y squared. So you see we have four values. So it's the same thing here. Somehow we are ending up with four values. Why? So the equation has an x squared and a y squared. The values are merged. But the vertex in the ellipse was 4. But this time the vertices are just 2. They are not 4. Okay? They are 2. They are not 4. Are you following? Don't get twisted. So that's it. So this looks like a reflection. The hyperbola looks like a reflection, one reflecting the other. So there is a point called the asymptote. That there's an asymptote line that the point that these two gets close to. It's like a reflection, but it gets to it, but it does not touch it. That line, the asymptote line. The asymptote line. We normally talk about it because it's a point that these two chords, if they keep shifting, they will shift because they don't touch. Or the hyperbola, they don't touch. It does that point when it cuts. So that point is called asymptote line. And how do we actually find it? We can find it. We normally say x minus h is equal to plus or minus b over a y minus k. Okay, this is for the horizontal always. That's the left and right. Okay, while for the vertical, it's now a reverse. It's now a over b. All right. So we now have x minus h. This the asymptote line, a over b, y minus k. Okay. This is how to be. So if they give you a value for the asymptote value, just know from the asymptote value that this is what you are generating from it. So you can actually find your values of a and b on the asymptote line. You can get your values to solve your equations. Most times, because normally sometimes you can give you the asymptote line value. So say the asymptotes of this equation is what? The idea of it is to help us, guide us, to point us back to the equation. So we're able to solve it. So it's as simple as that. Remember, that's b over a. I don't want us to just to burden ourselves figuring that how did we come about this? How did we come about this? That's just it. Okay? Alright?